So in this lecture, we will see the concept of set in Python. So set is actually a collection of items. So the items can be of different types, similar to that of a tuple or list. But one of the important peculiarity of the set is unordered. That is, items in the set do not have a definite order. So it cannot be accessed by means of index. So we will see one example. So I define a set S1, and usually the set, when you define the set, the elements, each of the elements in the set or items in the set should be enclosed in braces. So the element should be enclosed inside braces, and each of the element will be separated by comma. Each of the elements should be separated by comma. So this is a set. So if you just check for type of S1, S1 is my variable name. So if you just check for type of S1, it is a class set. And if you want to print the S1, actually you need to give print of S1. Since I am running in shell, I just typed S1. So you will be having the elements of S1 here. And consider I have another set, that is vowels. Vowels, I have another set, and I have the vowels A, E, I have different vowels, A, E, I, O, U. So this again forms a set. Okay, this again forms a set because you see each of the elements are separated by comma and all the items are enclosed inside braces. So this again forms a set. Then if I print this vowel, we can see the different elements, and you notice the difference. What I have given is A, E, I, O, U. But when I print the vowels, what I obtained is I, E, O, A, U. That is, the order is not kept here. Okay, so that is one of the important peculiarity of vowels. So it is actually an unordered pair of elements, so that you cannot call it by subscript also. If I give the subscript similar to that of a list, that is vowel of 1, it will show an error because the order is not kept and it cannot be called by means of subscript. That is one of the peculiarity of set. Also you can see, if I define a set SC1 equal to 1, 2, 3, 1, 2, 1, 2. See, this is a set. And if I just print this, print the set 1, SC1, print the set 1, SC1, you can see actually the elements I had as 1, 2, 3, 1, 2. Is it? But when I print the set SC1, what I have obtained is only 1, 2, 3. That is, a duplicate elements are actually eliminated from here. See, there are 2 1s, but only 1 is printed. There are 2 2, but only 1 2 is printed. That set does not allow elements to duplicate. So that is also one of the peculiarity of set. So there is the set is unordered, and there is no indexing, and there is no duplications of elements. Now, how you traverse through the set? Similar to that of a list or tuple, you can use a for loop for I in SC1. SC1 is my variable name. So if you traverse, that is I in SC1 means each of the elements of SC1 set to 1 will be traversed. So if you print I, what happens is each of the elements in set will be traversed. So you'll be getting 1, then second element 2, then 3. So each of the elements will be traversed. So this is how you traverse a set. It is similar to that of a list or tuple. Now, how will you add or remove the elements from a set? So if you want to add an element to a set, you can use the command .add. SC1 is a set name, .add. I want to add an element 9, SC1.9. So if you print SC1, you can see the element 9 is added. And if you want to add multiple items to a set, you can use the command update. Instead of add, you can use update. That is, this is for adding multiple items. So if I want to add multiple items, so that I again define inside braces. That is, I want to add the element 9. 9 is already there. Is 7, 4, 34, 23. So see, I use the command update in order to add multiple items. If you want to add only a single item, you can just use .add. If you want to add multiple items, you can use .update. So the elements 7, 34, 23 all are added into the original set SC1. So if you want to remove an item, if you just want to remove an item, you can use the command remove. And if you want to discard an item, discard method is also there. That is, if you use the remove method, the one of the element will be removed. If you use the discard method, it will remove the element. If the element is not there or not present in the list, it will not raise an error. For example, if I have a set 1, 2, 3, and if I want to remove the element, remove one particular element, I can use .remove. And I just give remove 4. You see, the element 4 is not in the list. So what happened is, it will show a key error. But instead, if I give discard is again the same function which is used for removing the element. So the element 4 is not there. I use the one discard. It doesn't show an error. So if it is present, it will remove it, else it don't show an error. That is the difference between these two. And you can use a clear method in order to remove all the elements or items in the remove all the set items at once. And delete method can be used, DEL, in order to delete the set. So if we access the set later, it will show an error because the set is already deleted. So you can use a clear, delete, all these methods are there. Now see, one of the main peculiarity of set is the relational operator. That is, we can use different operators like this. Less than corresponds to subset, and greater than corresponds to superset. Less than or equal to, greater than or equal to, or you can check whether two sets are same by using double equal to or not equal to. So these are different operations supported by set. Okay, so you can check case 1. You can check case 1. Consider you have a set S1 equal to set 1 comma 2, and consider you have another set S2 equal to set 1, 2, 3. Okay, and I want to check whether S1 is a subset of S2. You see 1, 2. Here it is 1, 2, 3. So it will show that S1 is a subset of S2. It will return true. Similarly, you can check for superset, get superset. Similarly, you can use a sign greater than or equal to, less than or equal to, or equal to, double equal to, or not equal to. So these are different operations that are supported by set. Now, these are the relational operator. Similarly, there are some mathematical operators. See, these are some of the mathematical operators. That is union. Union, it returns a new set which gives a union of the elements A and B. Okay. Similarly, intersection, that is A dot intersection B. It gives A intersection B. then A dot intersection underscore update B. So what happens is it changes the set A, it actually update the value of A with A intersection B. That is what happens. If you just give A intersection B, what happens is it just give what is the intersection of A and B. Intersection of A and B will be listed. If you give A intersection update B, what happens is it find out the intersection and A is also updated. A is also updated to A intersection B. Similarly, A difference B, that is A minus B will be listed. A difference update B means A minus B will be listed and it will be updated to A. Similarly, A symmetric underscore difference B, what happens is difference between A and B and difference between B and A. The union of all this will be returned. Similarly, asymmetric difference update B means what happens is the same thing. Difference between A and B and difference between B and A is union is taken, and what happens is it is updated to the set A. So these are the different mathematical set operations. So it support different set operations similar to that of our normal set. Okay, so there are relation operators and mathematical operators. So you can check for each one. You can check for different relation as well as mathematical operators, and these are all about the set. So try for different operations which are used and try for different examples and be familiarized. So these are the different set operations. So one you have to keep in mind is set is actually an unordered collection of data. There is no indexing and no duplicate. Okay, thank you.